Hi everyone, welcome to the third part of my structural analysis video. In this case, it's actually the last part for the SAP 2000 software. In this case, we're going to analyze a rigid frame. So we have the given material properties, its assumptions, etc. We have the loads, the dead load, 31 kilonewton per meter, and so on and so forth. We have the load combinations, section properties, the sizes of the beams and the columns, and of course, we have our reference figure. And with this, we'll be able to identify different values. For example, the reactions of specific support, the shear, the moment, etc. Also with the actual forces, and so on and so forth, and the maximum, the minimums. So let's go to our software. So this is our software, and what we're going to do is to add a new model, and we really have to wait for some time because it's really loading, and now it's prompting that it's not responding. Basically, this software is really heavy, particularly for my device that is only having a Pentium processor. Please respond already. It took a lot of time. Okay, thank you for that. And of course, we are going to use the 2D frames, and yeah, from there we already have checked that the units are already in kilonewton. For the force, the meters for the dimensions, etc. So here I'm going to input for the number of bays installed is there are 2 from our given figure. Height is 5 per base, and bay width is 6 into the 6. I'm gonna click OK. Then it will lead me to the command window, and since I'm not going to use a 3-dimensional analysis, so I'm gonna exit the 3-dimensional view and we'll focus on the 2-dimensional view. So what I'm going to do here is this is not actually the exact figure, and what I'm going to do is to modify the figure, since this is what this is not according to the given. So I'm gonna delete. You can actually delete the members in order to modify them. I'm going to delete these members. I'm gonna replace them with the exact sizes, lengths, and etc. And after that, I'm gonna edit the gray data and modify. Then I'm gonna modify this into 4, since the direction from this point node G is actually 4 meters to H. Now, and for along the stories, so the inputted data a while ago was actually 10 meters now from the ground or from the support from point F. So this is actually 9. So I'm gonna replace it with 9. And click and then OK, and then OK, and then there it has changed. And then I'm gonna put or applied new members, then click, and then yes, that's our final structure. And then what we're going to do next is to define our or assign our supports, and those supports. So we go to the assign to the restraints, and then we click what type of support has to be added according to our given. So that's actually a fixed support for these nodes, that's nodes F and G. So I'm gonna click OK, then apply, then it will change eventually, and then like that. And I'm gonna highlight this and then apply a pin support for this node, that's node H, and click OK, then apply there and click OK. So that's it. That's the actual form or the actual figure of the structure. Then what we're going to do next is to define the structural properties or the materials first. So let me define the materials. So our material is actually a concrete, and I'm gonna add a new material and define according to the concrete. Then click user and then click OK. And then you have to modify these values from our given. That's 84 kilonewton For the unit weight, so I'm gonna put 24. This is actually 21 kilonewton, 21 kilonewton per square millimeters. So I'm gonna put this 21 million. Well, that's 6, and then this is 0.0000012. Then click OK. And then click OK. And after that, we're going to define our structural properties. So go with the frame section. We import new property. So it's actually as concrete, and then rectangular. And then I'm gonna name this. Let's go first for the columns. Our columns is actually 400 by 400 mm. So I'm gonna click this 0.4. 0.4. This is a legal value. Then the concrete. That's it. And then we click OK. And then after that, we're going to add a new property for the beams. So I'm gonna name this for beams. Beams. And then our property for the beam or the rectangular section is actually 250 by 350 mm. So I'm gonna put this 0.35 by 0.25. So in the right pane of our figure, this is actually a representation of the beam in reinforcement. So that's some sort of advance. So let's click the concrete, and then there we have the property, and then click OK. Then we have the properties, material property, section property for the beams and the columns, and then click OK. And after that, since we have already assigned or defined the section properties and the material properties, let's now assign them to the beams, to the members of the structure. So for the beams, you just click assign, just highlight the structure, then frame section, then gonna click beams, then click apply, and it will actually prompt if the beams that specific property is already applied. And after that, we're going to assign the columns. I'm gonna highlight the columns. These are the columns, and then click apply. So I already have applied highlighted columns there. So these are actually indicator or indication that the beams and the columns are already applied to its specifics. Then click OK. And after that, what we're going to do now is to define the load patterns and load combinations. For the load patterns, just click load patterns, define load patterns, and then I'm gonna add a new load that's a live load. Live, then I'm gonna choose live here. Let's add new pattern. And next is I'm gonna add wind. Then it's wind. It's still 0, and then I'm gonna click this none. And then for that, I'm gonna add new pattern and then click OK. And after that, we're going defining the load combinations. You just have to add a new load combo. Then I'm gonna name this load combo as case number 1 for the with respect to our reference for the given problem. So that's case number 1. That's actually 1.4 times the dead load plus 1.7 times the load. So I'm gonna click the dead load that's already there, and I'm gonna input the scale factor that's actually 1.4. 1.4, then click add, and then for the live load, that's only for our case number 1. So there are actually two cases, the case number 1 and case number 2, with different scale factors. So that's 1.7, and click add, and then OK. Now we have generated our load combination. Next, we're going to generate our second case load combination. So this is for the case 2. Case number 2. Sorry. And then, oh, I forgot. It's supposed to be linearly add. I mean in SRSS. So this is live load. This is 1.05 from our problem. And 0.5 for the dead load. For the live load, that is 1.275. click add, and for the wind load it's 1.275, add, then click OK. This case, just let me modify this case. Modify this. This is supposed to be SRSS. Then okay. Yeah, let me check. Okay, and after that, I'll click OK. Now, after defining the load cases and the load patterns and load combinations, let us now proceed with applying the loads. For the dead load, let me assign. So let's go with the frame loadings, distributed. That's a dead load is actually 31 kilonewtons, if I'm not mistaken. Yeah. That's 31 kilonewtons per meter. So the dead load, it's 31. Uniformly distributed load. Now, to avoid confusion, when we are actually going to apply specifications for the applied load, for example, the point load. So it depends on which way of application you are going to use. In this case, since I chose the distributed load, so it is already programmed, in the software that it is going downward. Even if I'm going to input a positive value, not on the other case where if the load orientation is going downward, it's negative, and if it's going upward, it's negative. So let's proceed. So that's 31 kilonewton per meters. Then click apply. Then it will. Oh, I'm sorry. Actually, we are going to apply that value to all the beams. And also apply this. All the beams, the dead and the live loads are applied to all the beams, while the wind load is applied to specific nodes, of the build of the structure. Then, oops, it's supposed to be a live load. Ayan, live load. Next is now we click add to existing loads. That's for the live load. After that, that's actually 10 kilonewtons. Now you have to take note of this, because if you're going to click modify and add a new load and click this option, which is replace the existing load, it will actually remove the existing load and replace it with the new inputted load. So upon adding for the live load, I'm gonna click add to the existing load. Then click add. From the live load here, from the dead load there, I'm gonna click the live load, then input the value. That's 10 kilonewton per meters. Then we click apply. There. Then after that, we're going to apply the wind load. So our wind load, I'm gonna assign this as a joint load. This is this node. A wind load that is actually 40 kilonewtons. From that end, that's node A, 40 kilonewtons. This is force, global force X. It's going, that's positive, so it's a positive value. This is what I'm trying to imply. Next is we're going to apply it. Then wait until it applies. Second is we're going to add here at this point, it's 20. Then I'm gonna click this node, click OK, and then there. So we already have the loads. So there's nothing else that we have to do and beside the analysis. So let's go and run for analysis and see for the results. So I'm gonna click this, then this, and not that. Then run analysis, run now. I'm gonna save this as C. It's actually a rigid frame. save. And then it will, upon the analysis of the software, it will expectedly show me, I'm expecting to show me the displacement. Let's wait a little further. As you can see from here, there. So this is the displacement of the figure. No? So if you're going to tap this button here, the nodes here, it will actually show us the value. So what we're going to show now is the reactions. Let's look for the reactions joints according to the dead load. Let me show about the tabulated, no? The dead load. Right there. So our dead load. Actually, here we are asked to identify the reaction to support F. So we have to disregard disregard the value because that came from the previous use of the software that is TAD. So, tabulated, and I'm gonna apply. Yeah, and those are the values. So actually, these are the if I am going to into this according to the arrows, no? So tabulated. If you have confusion determining which are the horizontal, the vertical, in the moments, basically this is the moment. We have values for the moment 60 and 193. That's kind of difference. So you can also view the values. Okay. Also the values by clicking display and show tables. Then element output, and then click OK, and there we can see the values. You can see the values. That's it. Thank you for watching, and I hope you learned something about these videos. And yeah, have a good day. Bye.